I will start with the story. Once upon a time, in about 15th century, Europe was in a hard place. The Roman Empire had collapsed, and Europe was hostile nations. Nothing really happened because the trade routes that were available then went through the hostile nations, and any expansion was driven by wars between nations in Europe. So it was a zero-sum game. And time passed, and a few interesting things happened. The map making became better. People started using compass. Ships became better, and eventually trade routes or sea routes to China and India and Americas were discovered. But shipping in those days was dangerous, and you could send the ship away. It might come back or might not, but you'll find out after a couple of years. And if the ship comes back with some good stuff, then everyone becomes rich and happy. If the ship doesn't come back, it's bankruptcy and it's over. So and it went on, and it was all opportunistic. Then traders saw an opportunity and came together and created trading organizations. British East India Company being the most well-known, but there were others, including Swedish East India Company based in Gothenburg. And they poured together resources, invested in shipping technology, and make it all work much better. And ships became faster. So instead of sending one ship to a predetermined location, they can send many ships to many locations. And if one mission fails, then it's not the end of the world. Also, ships got faster, and it became like a race. The ship that arrives first takes the good stuff, or a year's supply of the good stuff, or spices or gemstones or whatever. And the ship that arrives second there's nothing left. So this competition led to a yacht race between London and New York's yacht clubs. And as the race went on, the winner had finished, and the admiral informed the Queen Victoria that the yacht from New York had won. And the Queen asked her admiral, like, who's the second? And the admiral responded, well, my Queen, there's no second. So what I'm trying to tell with this is we do shipping. We just ship software. Instead of tall ships, we have pipelines. And if you look at it, there's no second to companies like Google, Facebook, and Amazon. This is the story of going from plan-driven, big, slow ships, taking a few years to arrive, to being much more agile and much more flexible in delivering value. And it's not like continuous software engineering is the same as plan-driven, just faster, or agile, just faster. It's a completely different way of looking at engineering and a completely new way of creating value. So it's not like distinct steps. It's more like a scale. On one end, you have big, slow ship that might or might not come back. Like, all the risk is happen only a few years. Like, you release software, or not release, you start building it. After a few years, you release it, and then either you succeeded or not. With continuous, you release all the time, and you can make course adjustments all the time. And an analogy would be like a fleet of small and fast boats that use opportunities as they arise. You don't have to send them in a specific direction. But they pick up what makes sense and come back. And by coming back, you can make a better decision where to send the next boat. And the critical part of this is data and automation. You have to have data to make better decisions. You have to have automation to be efficient. So I will be mentioning speed, and I want to make it clear what do I mean by that. The famous Bruce Lee said that he fears a man who has practiced one kick 10,000 times and doesn't fear a man who has practiced 10,000 kicks. You can say that you're fast because you can release 100 features every month, what that speed really gives you. It gives you a product that has a lot of features, and none of them is really good. Well, some might, but you never know. With the other interpretation, you get a chance to fine-tune one feature many times and perfect it. So I'm not saying one is better than the other. It's just you need a bit of both. And with this better speed, better automation, there comes a promise. And this is what you can read in any book about continuous software engineering. That it's going to be effortless. It's going to be much different. You'll have better communication with the customers, shorter feedback loops, many, many benefits. And it's going to be exponential advantage in the market. And it kind of looks like this from the outside. And but what is not so known are the assumptions. First, CI/CD is not for everyone. You don't want someone to make the continuous update. So there are limits where you can apply CI/CD and where you better not. It's not that you can't benefit from the continuous idea, because continuous software engineering is like an umbrella term, similar to Agile. And you can still do things in a continuous way, but you don't implement CI/CD as per book to a safety or mission critical software. A big assumption is that customers want continuous upgrades. I think all of you had experienced this thing when you have some important work to do and your computer decides to update. Now imagine that happening many times a day. You wouldn't be happy about that, and it's exactly that that the customers might refuse to give access for updates, especially if they're downstream dependencies. If it's a business system, they don't want the updates. And what's even more important is that even if you convince your customers to accept those updates, the organization, the software vendor, might not be able to figure out the business model, because it doesn't make sense anymore to charge per release. Like, here's a release 1, it costs X amount of kroner, version number 2, the same amount again, or something like this. It's not transactional anymore. The business model has to be service oriented. I think software as a service is important for the business model, but going from one to another, it's a large undertaking. So what we learned from the companies is that implementing CI/CD in an empty place is not that difficult. It's an undertaking to change the ongoing systems, ongoing products. It's really hard. And when automating, it's not like you can just automate everything. A good example was in one of the companies we worked with. They had a development team that created the release and wrote the documentation how to update software to the latest release. And it's a long document with lots of things and many points of failure. And what usually happens, the operations team reads the documentation, messes something up, calls developers come fix it. So it kind of went on. And if you do it twice a year, well, you live with that. And they started to think, like, how do we make this better, faster? They realized that this long Word document can be replaced with very simple install script. So they throw away the documentation and replace it. When you look at it, it makes sense. But if two organizations has to agree that let's throw documentation away, I'll give you a script. That's not that easy. Also, is that the customers, especially if these are companies in telecommunications domain, they take vendor software and build something on top. So there's a kind of intricate integration on the software layer. So they want to be sure that nothing's broken. They don't want to give away the control of the software to someone else to update it. And what's more important is that sometimes companies build a business process around something that software does. And they definitely don't want someone from the outside to change that feature that they rely upon. It might be better overall, but because the business depends on it, it's even a bigger change, bigger adjustment. So and it's not the engineering part that's is hard. Well, it's hard, but the hardest part is the organization transformation. So yeah, it's not easy to go from not client-driven or even agile to continuous, because it's different. And we have this research project, Continuous Everything, where we try to understand what makes sense, because it's assumed faster is better, and that continuous is going to solve all your problems. What we try to do is we try to break down what the continuous actually is, what are the investments companies have to make, what are the benefits of those investments, and where the balance is. Also, how to make the best use of those advantages given by continuous. And every company we talk to ask, like, okay, we have done already something. What's the next thing we should do? And we work with Spotify, Eriks, and a company to get a good picture. So when we started this work, we asked ourselves, okay, what does it mean? What is continuous? And we looked at the literature, what's already out there, and tried to build a kind of model, the perfect CI/CD pipeline. It turned out to be a really complex thing. I'll come to that, but to understand the full model, I'll present simplified model. And this kind of is a good conversation starter, because every organization does planning. Doesn't matter if it's continuous or not, but there's someone coming up with ideas what to build. There's a development and testing organization that takes those ideas, turns them into software. That software is released and operated. Customers use it, provide feedback. Whether the feedback is used, that's a different matter. But so there's a loop going from planning to development to releasing software, customers using it, and companies use customer input to feed the next cycle. So, and the complex model starts with the 4 organizations or 4 levels of one organization. The top one is engineering. That's easy. Then there's product, where planning takes place. We have operations, is the organization that actually operates the software. And at the bottom, we have end user customer. These might be different physical organizations or units of one organization, depending on, is it in-house software? What is it? So, but that's not really important. The important is that there's a boundary that software has to cross. And when the software is taken from one organization or unit to another, sometimes it's like throwing something across the fence and making it someone else's problem. Just want to highlight that here. So everything starts with planning. And continuous is, well, it's short, it's flexible. You don't try to build up huge roadmaps. It's a quick plan that can be quickly executed and delivered. Plans go to engineering that does all kinds of activities, development, testing, compliance verification, whatever it takes to build the software and make it work. And the result of that is always ready to be deployed, ready to be delivered software. And the key difference is that even in Agile, when you build a feature, you put it on a shelf. You build another feature, you put it on a shelf, and then the sprint comes to an end, and then you show it to customer. Oh, we have these 10 new nice features. But while these features are lying on the shelf, they're not generating any value to anyone, and they doesn't generate feedback. Are they any good? Maybe they're really bad features. So you never know until you release it. So we'd continue to release immediately and immediately start getting feedback back so we can adjust. So from continuous deployment, it goes to continuous delivery, where the software is actually available to the end user. This, in an ideal scenario, this is all automated. So once the commit, push, merge, automation takes over, and if all checks pass, software is out there. Then the software is available to the end user for using it. And this is kind of one of the maybe differences with other types of software development. When you sell your customers software releases and charge your customers for a specific release, you don't really care if they use your software that much because they already paid. Here it's different. You actually want your customers to use the software and monetize it. This is where software as a service comes in. But that software as a service is one example how you can monetize it. And with the continuous use comes continuous feedback. Customers use the software, click and point and do things that you can track. And they write App Store reviews, provide you feedback, and generate all kinds of data that you can use. And also, as this goes on and you continuously deliver good software that actually solves customer issues, the trust increases. And with increased trust, you can try out new things. You can do continuous experimentation, release an experimental feature to collect feedback. Is it any good? And if it's good, then you continue. If it's not, then you kill it and try something else. And all this data goes into continuous monitoring and analytics and feeds into the next planning cycle. And the faster this loop goes, the faster organization can benefit from new opportunities. So it's a big difference. If you see a good market opportunity and it takes 3 months until the budget committee comes together to decide if this is any good, and then 3 more months for someone to draw up an architecture, then half a year later you have some prototype, but the opportunity is gone already. With this continuous model, you can, in theory, come something out next day, and day after the feedback is coming back, and is this good or not? A really good example is Microsoft had this search engine Bing, and they wanted to know which shade of blue for the links make customers click more. And they experimented with different shades of blue and found a specific shade that on their scale increased their revenue millions per month. Because customers clicked on ads, there's a specific shade of blue that makes them click more. But you can't ask a customer, like, which shade of blue do you prefer to click more? Like, what kind of question is that? Like, if I wanted blue, and that's it. But with kind of small tweaks, you can find the sweet spot, and not just for the colors, for everything the product does. So and there are also the cross-cutting concerns. I mentioned continuous experimentation. There's security, innovation, continuous improvement. Because as you go through the loop many times, you collect data of how efficient it is, where are the bottlenecks, and you can tweak it so it becomes more efficient every time. There is continuous budgeting that I find it fascinating, because every organization, doesn't matter how agile they think they are, they do their budgets per year or per quarter. But it's exactly against the flexibility and agility they hope to achieve, because if I have the business opportunity now, I need resources now, not 6 months from now when the committee comes together again. So it touches upon this thing that the organization has to actually change and become flexible to make the best use of continuous engineering. So and we showed this model to a number of companies and use it to kind of analyze what they have already and what they would like to have, and what are the challenges and how do they go with it. And to explain it, I'll use the simple model again. So most organizations automate something already. Could be tests, some integrations, and it's the developers who figure out that tedious tasks are better to be automated. They do it, and that's where it all starts. Some even go as far as proper CI/CD, maybe not all the way to the customer side, because that's kind of the boundary it's hard to cross. So it's kind of no-brainer. You automate something that is repetitive. It's a huge gains in efficiency. Everyone's happy. What is not so easy is this part, because first is convincing customers that now it's going to be very different. how they receive their software, especially if it's business critical, like big telecommunications or domain, and to convince organization that now we're going to be using data to make decisions. It's just not easy. And the reason for that not being easy is that with continuous testing, you can say, well, we spend 10 hours every sprint to do something repetitive, regression testing. If we spend 100 hours now on automating it, we can that's easy cost benefit calculation. But it's really hard to calculate, like, what's the value of continuous customer feedback? How do you put the number on that? And there's no good answer. But we are trying to explore it. So when we show organizations this, they say, well, great, we have done already something. So what's the next step? And we definitely want this, but that's going to be hard. And how much of this do we really need? Because not all organizations has to go the full cycle. Maybe an organization just wants to become more efficient in development. They can use the continuous principles to make that happen. So we came up with a hierarchy of opportunities and challenges. It's 6 levels. It kind of illustrates how you go from nothing to something. The bottom layer is I think it's the most important thing, because if you have an ongoing product with customers, with money coming in and kind of process around it, you can't just stop it and say, well, we're going to throw it out and start something new. You have to provide support for the old software delivery method until the new one is fully operational and you have upgraded everything to make it work and switch completely. So for some time, you have to maintain 2 separate software delivery methods. And it takes about twice as many resources to do it. So it's kind of essential to not to break everything immediately. And from the level 1, it's easy, not easy, but the obvious step is to start automating from the bottom up, small things. Like in this model was built for a big company that builds many components and integrates them together. So first step for them was to identify opportunities for automation in each component individually, improve efficiency there. Once it's done, you can start synchronizing delivery pipelines between different components and bringing it all together here. But it's hard when you have components with interfaces that are not really automatically connected. So it's a challenge. And once you have that, you can aim for continuous solution delivery. But this is where you have to actually talk to customers, make new agreements with them that they're going to give you away control of their production environments for you to be able to deliver software. And that's new contracts, new everything. And from what I have seen is that only few companies that I know of are here. Most stop somewhere here. It's not a bad thing, it's just how it is, because this is hard. But what happens is once you have some automation in place, you can start collecting data for fine-tuning and planning. You know that there's a component that's always slow or always breaks, but you know it by looking at data, not by asking someone how it's going. So you can track improvements and you can track investments and see, does it really make the metrics go where you want them to go? And assuming this all is in place, there's this 6th level of evolving business models. This is where you have a fleet of small boats exploring the world and using opportunities as they arise. Yeah, I'm looking forward for an organization that's really doing this, and we can see how they do it. But so this all aside, so when an organization comes to talk to us, it's like, okay, we want to be continuous. We usually ask, so where you are now, how fast are you? What exactly you want to improve? Because it's not like continuous is good, everything else is bad. It's like, it's a tool that helps saves times in some ways. So it's calibrating the organization, and one tool for calibration is implementing some of the continuous principles. What organizations usually do, they invest money in teams, tools, automation. And there are changes in quality, cycle time, release cadence. And if that's measured, and also changes in customer behavior, because investments are not there because some tool is nice and trendy. It's because the aim is to make a better product at the end. And what we can do with data is we can look at changes in customer behavior and use that as an input to see what is the optimal release cadence, what is the quality. Maybe we are overdoing it. We're investing too much. Customers don't want that. So we can maybe lower the bar a little, make it easier for everyone, but still have better customer behavior. And of course, that feeds back to investments, like where to invest. And as an example, what we can do is we can look at the release time. Here on the horizontal axis, it would be time, and the vertical is some sort of customer behavior that you want to improve. And so you have a release cadence like this. You release, the release 2 is really good. It's much better than the release 1. Behavior goes up. Release 3 is, well, not that good. So the behavior down, and it kind of continues. And seeing this, someone might say, yeah, just you do continue, be faster, and it's going to be good. And it looks like this. And who says this is better? So, but what we can do, I hope to do, is to collect data for organizations to be able to actually put a number that an optimal cadence is not 1, it's not 4, it's maybe 2.5. And not just for cadence, for quality and other metrics. So yeah, it's the point of all this is to make not just to play around with interesting things. As Javier mentioned, we like to work with companies a lot, and the work I just showed is most of the ideas come from discussion with companies. So it's looking forward to collaborate, and we have 2 items in the menu. One is an inventory. Your companies are doing some parts of this already. So we can use the models that we have to kind of understand where are you now and where do you want to be and where you should be, and help you to figure out like what's the next step. Where do you invest? What do you automate? Maybe there are things that you shouldn't do at all because it might be detrimental. And on top of that, we can look at metrics. What you already are collecting, what you should be collecting, are the metrics actually useful to measure the things you want to measure? So we are open to send me an email, come talk to me, and I'll be happy to see what we can do. And well, if you have one slide to remember from this whole presentation, remember the ships. It's not like one is better than the other. But once you go from operating one big ship to operating many small ships, and it's not easy because, well, with one ship you can do the accounting and planning, let's say, on a notebook. When you have hundreds of ships going 100 different directions, it takes a whole system of accountants and clerks to make sense of what's going on. But once you have that in place, the organization goes from being a trading company, becoming a fleet management company. And then it doesn't matter what the ship actually brings back and what's being traded. Then and a good example of this is Amazon. They went from being a bookstore to becoming the largest value chain management company. So you can buy anything on Amazon. It doesn't really matter what you buy and sell because it's the infrastructure that makes it happen. And the business kind of changes completely. Thank you. And Get in touch if this was interesting. Thank you.